Now let's look at CPM. CPM is about cost-time trade-off, and it's called project crashing. Project crashing means we reduce the time required to complete the project. So when would we do that? Well, when the project is behind schedule, or if there is financial incentives to finish the project early. That may be sometimes bonuses awarded if the project is completed before the due date. And also in some instances there may be penalties involved if the project is not completed on time, and it may be worthwhile to expedite certain activities. Okay, shortening the duration of the project is called project crashing. Now, what are the factors that we need to consider? The amount by which an activity must be crashed or permissible, how much crashing can be done for each activity. Okay, taken together, the shortened activity duration will enable us to complete the project within the due date or not. And the total cost of crashing must be as small as possible. Now, steps in crashing. The first step is to compute the crash cost per time period for each activity. Okay, and that is computed with this formula. So crash cost is the total cost involved after crashing. Normal cost is the normal cost. So this is the total difference in cost divided by how much crashing can be achieved through this additional cost. This ratio will give us crash cost per period. Now, using current activity times, then we need to figure out the critical path. Now, remember, non-critical path is not going to affect your project completion time. So there is no point in crashing non-critical activities. We need to crash only the critical activities. Then we need to go through a process. If there is only one critical path, then we crash the cheapest activity on that critical path. But if you have multiple critical paths, then you have to choose one activity from each. Or if there is a common activity, then you can use the common activity and make sure that that is the least cost activity to crash, and then you repeat this process until the desired completion time is achieved. Now here is an example. This, you have A through H, normal time and crash time. So which means in the normal conditions, these are the times, and crash time represents the smallest possible time by which an activity can be completed. So for example, if you take G, in normal conditions it will take 5 weeks, but it can be done in 2 weeks. So there is a 3-week worth of crashing that can be done for G. And the next two columns are normal cost and crash cost. Normal cost is with respect to the normal time. Again, going back to G, under normal conditions it will cost $80,000 and we can finish it in 5 weeks. But an additional $4,500, you can finish it in 2 weeks. So this is the crash time, crash cost and crash time. So to find the crash cost per week, we take the difference between the two times and divide it into the difference in the two costs. Now we do that because we are assuming here that the cost of crashing is linear. Okay, this is about activity B. The normal time is 3 weeks, normal cost is $30,000. It can be done in 1 week, but it's going to cost you $34,000. So cost of crashing per week is $2,000. And we are assuming that we can crash by any amount. Okay, if we crash by 1 week to 2 weeks from 3, then your cost will go up by $2,000 to $32,000. If you crash half a week, then it will go up by half a week times 2,000 weeks per week. So that means it will go up by $1,000 and you can finish it in 2.5 weeks. So linearity here means you can crash by any amount between the permissible times. And the increase in cost will be prorated at the rate of $2,000 a week. That's what we are assuming for all the activities. So in our example, so here is the critical path A, C, E, G, H. So A, C, E, G, H, which one is the smallest cost activity to crash? So let's go back to the table. A, C, E, G, H. So A, C, E, G, H. And of these, A has the smallest cost, not F, because F is not a critical activity. You have to look at only the critical activities. So you can now crash A, and the amount of crashing allowed is 1 week. So we have to repeat this process until we achieve our desired results. So let's go back to our numerical example and work it.